Welcome to my channel. In this video, we're going to learn how to use a truth table to prove that a particular disjunction is a tautology. So in our case, we have P implying Q or Q implying P is a tautology. So first of all, we're going to highlight the special things about the propositions that are involved here. So the first case is the implication. So for P implying Q, it is only false at one point. That is where P is true and Q is false. So that is what is special about P implies Q. And then for Q implying P, it is only false when Q is true and P is false. So that is for the implication, the first implication, and for the second implication. But for the disjunction, in a disjunction, the special thing about this, like in our case, we have P implying Q or Q implying P, it is true. So this is true if at least one of this is true. That is at least P implying Q or Q implying P is true. So let us now use a truth table for this particular truth. Okay. So in our truth table, we're going to have implying Q and the one for Q implying P. Then finally, we're going to have the big one, that is P implying Q or Q implying P. Table, we have those columns. We have P, Q, P implying Q and Q implying P, and then the disjunction there. So for P and Q, we are going to pick all the possible combinations. So there is a first combination where both are true. There's a case where P is true but Q is false. There's a case where just P is false and Q is true. And then finally, there's another case where both are false. So those are the only possible combinations. So according to what we did prior, when you look at P implying Q, we said that it is only false when P is true but Q is false. So that is here. So this is the only. Then for Q implying P, it is only false when Q is true but P is false. So let us look for the instance where Q is true but P is false. So that will be here. So it means it is only false at that point and it is true elsewhere. So now for a disjunction, we said that for, like in this case, P implying Q or Q implying P, it is true if at least one of these is true. So long as a true value appears anywhere, then it will be true for this case. So let us look at the two cases. So here there's T and there's T. So it means there's T and T, it will be true. So the proof is there. Now that we have all true values for the column for the disjunction, it therefore means that our expression is a tautology.